All right, hi everybody. So here's hopefully a little bit of a quicker version of taking a look at those interferograms with the beach balls and the focal mechanisms. The idea here is you can kind of check what you already did from last Wednesday. If you haven't finished, maybe this will hopefully clear up some confusion if there is any, and how to. It's. I know it's weird looking at these focal mechanisms and the beach balls and trying to see what they look like in 3D. So I'll kind of give you some of the ways that I look at them. Maybe that'll help you and help you see it similarly. All right. So we'll try to do that. Kind of show you what the rightish answers are, and then this should give you enough information to do what was assigned last Friday with all those different focal mechanisms. There's already a video that shows you how to do that for last week's, but now that you have this new piece of information, that'll give you some extra information to do that assignment maybe a little bit better and offer some clarity as opposed to what you had just with the minimal amount of stuff we talked about on the video last week and in class last week. So I'm not going to add anything extra on your plate for Friday for this week. This will just be kind of correct this. You can turn it back in and then also take a look at the other focal mechanism assignment from last Friday and put some time into that. It's probably taking a little bit longer than I anticipated for some folks, so um, I think it's fair to give you a little bit more time. Alrighty, so without further ado, let me try to share here. I have a sleeping dog next to me, so I'll try not to wake him up too much or anything. Um, so here's what we got going on. Actually, I'm going to turn off my video so that you don't have to see my bald spot sticking up or anything. Okay, so I think we're on the right screen, looking over here on my shared screen. So here's the actual kind of matchy-matchy of the different faults, and I'll show you how we know these different faults match up with what right now. So the first one, interferogram 1, matches up with focal mechanism D, and last week and Wednesday we kind of already drew the fault through there. You guys saw that pretty easily. You could see the offsets. We figured out that the blue, yellow, red, let's see here. There it is. Blue, yellow, red right there. That means the land dropped. So the stuff on the left-hand side of the fault dropped, or in this case, the west side. Stuff on the east side went up a little bit. And if you remember, each one of those rainbows represents, give or take, let's just say 2 centimeters, give or take. All right, so it'd be like 2, 4, 6, 8, 10, 12, 14, 16, 18, 18 centimeters to there, plus whatever it's hard to count by human eyeballs there. So you would have computers interpolate that for you. Um, but maybe a total of 30, 40 centimeters of uplift and down drop, which is, let's see here, 12, 13 inches. It's not a whole heck of a lot in terms of earthquakes. All right. So anyways, there's our fault. I kind of drew the fault here for you already. Let's see. I will make that a little bit darker. Maybe that's what I want to do. You guys already did the fault, so maybe I'll do like this. All right, so there's that fault. So how do we know that this is the focal mechanism over on the right that matches this one up? Well, you got two options here, and we talked about these beach balls and the focal mechanisms. Basically, the lines that are on here represent the two possibilities of the fault plane that earthquake could have had. And so if you take a look back over here at our interferogram, I think there's a pretty awesome ability to match up kind of this northwest um, to southeast trending strike of the fault that's right there, or the direction that it's pointing. And so because that strike kind of matches up with that strike, that's a good way to match these suckers up here and figure out that, hey, this is indeed the fault plane of this particular fault. And then you need to figure out, all right, well, what kind of fault was that? So remember, I told you the white, if you kind of think about how to read these in simple terms, is the white kind of pushes the blue. So, like, man, that's a loud truck outside. I apologize. So the white kind of pushes the blue like so. And if we were to draw these like the really fancy fault arrows, all right, that means that side of the fault is going this way. This side of the fault is going that way. And if that was a strike slip fault, basically if you're looking from uh, going from left to right or from the left side of the fault to the right side of the fault, you would see that this portion over here, all right, is pushing the blue to the right with respect to if you were standing like over here on this side, okay? And the same thing is true for there. If you're standing over there, it looks like it's getting offset to the right. So this would be a right lateral strike slip fault. Remember, anytime you kind of get this peace sign, that is like the hallmark, or not peace sign, uh, BMW sign. That's like the hallmark for strike slip. I think I was thinking peace sign is Mercedes, but I was thinking BMW is. Anyways, sorry. So one other thing I forgot to mention. So once we get that fault and we know that that's the direction, that's the correct direction, um, while I was doing this, you basically just ignore the other possible fault solution. So we don't even care about that other side. Now what we know is like, hey, this matches up with the interferogram. That fault, oops, matches up with trying to get my mouse so I can drag it over here. Sorry, I lost my mouse. So that matches up. So literally, this is a right lateral strike slip fault. And if we were to draw that on here, if we were to draw that on here with the correct arrow here, literally it would look something like this. Okay, and I guess that's orange and probably not showing up super great. So let's see if I don't want to green. Do it dark brown maybe. All right, there you go. So that's kind of how it's moving. It's a right lateral strike slip fault. And this one, by the way, happened in, let me check my notes here. Oh, that's the Ridgecrest earthquake from Southern California. Duh, forgot about that one. Okay, now for the next one then. The next one is kind of the funky one that we were talking about in class that looked like this. And it turns out that this is from a sequence of earthquakes. So there'd been, I think, several fairly large earthquakes in this sequence. This is from Turkey, by the way. And we were kind of thinking about, well, maybe, just maybe, the fault was maybe kind of running like that, or maybe another one was a fault like that. And there totally could have been a rupture and a fault like the second one that I just drew right here. Okay, I'm putting a little question mark there. But out of all the focal mechanisms I gave you, and I will say this was a very difficult one and kind of a wild card, is the one that this matches up with is focal mechanism B. And you're like, what? How is that possible? How is that focal mechanism B? Well, I think I didn't draw my line quite straight enough, but let's see here. It's going to look a little something like that. All right. And so what we're seeing here, kind of the overall motion that we're looking at, this too is going to be what is, for all intents and purposes, is kind of basically a strike slip format there. Oops, hold on here one second. Sorry, I just wanted to redraw my line so it looked a little bit better for you guys there. Um, so, like I said, there was a series of earthquakes here. This one was in the Turkey region. Um, and it is going to be a strike slip fault. So there's two possibilities here. This fault over there, that fault plane, that solution, that's probably not going to work out with this, because if that were the case, it would kind of be trending more like that. So for us, what we know here and what we can see with these different fall offsets is uh, this one, oops, gosh darn it, this fault like so is a pretty doggone good match for if I were to go like this, boop, kind of run the edge to the edge. Get rid of this sucker so you can see a little bit better. That looks pretty good like that. Okay, that's a pretty close match. And so if you remember, we talked about white pushing blue. So in this case over here, white's pushing blue that way, white's pushing blue that way, which would mean that in this case, if that side of the fault's going this way, this side of the fault over there is going that way, this would be also a right lateral strike slip fault. Now, this one with the question mark, that was probably another fault triggered in that sequence that happened, either a day before or a day after. I don't remember the exact order that this one went. This one was from back in 2023. But there were two faults that kind of intersected there, and one triggered the other. So all we're looking at for here for this one, that's what this focal mechanism is showing us right there, is that right lateral strike slip along there. Okay, so that's that one. Let's see here. Now, by the way, also for these strike slips, you generally get more of a butterfly pattern, like equal lines of up and down on either side of these faults. Um, for this one, it turns out this one was somewhere in China. Let me double check here. Yeah, Akyol, China, A-K, or no, A-Y-K-O-L. That's how I spell it, A-Y-K-O-L. Doesn't really matter. But here's the fault going right through here. You guys found that. And you noticed on Friday that, or excuse me, Wednesday of last week, boy, oh boy, Wednesday of last week, when you go blue, yellow, red, this is our dropping land, okay? And then over here, this was kind of our uplifted land. Uplift like so. And you're like, okay, Hollister, well, if these are our two possible fault planes, what I want you to imagine is you're looking at the bottom of a circle. And so if you kind of did connected the ends of this fault plane like that, all right, and kind of made this was like a hemisphere, like let's see here. So you can kind of imagine just like a 3D cutoff disc or something like that. Imagine like an arch in an airplane or something, airplane wing. Um, if you can kind of imagine this line right there, well, take a look at that. Do you notice how that lines up really nicely now with this fault plane right here? So that's what we're looking at, okay? This, that's the fault plane. This is the fault that we're looking at. So that's how we matched up this focal mechanism A with number 3 over here. And so the next question becomes is, all right, well, what type of fault is this? And so if you're looking over here, and maybe I should clear away some of my drawing here so you guys can see underneath. If you look at all this, all right, remember the whites push the blues. And so in this case, you got to think that here's pushing, here's pushing, here's pushing, here's pushing. And then this is kind of being popped out. So like if you squeezed a tube, if you squeeze a tube of toothpaste, how if you squeezed from the outside where the white is, the blue would kind of squirt up and out at you. That's what's happening right here. Okay. And remember, anytime you have that blue that's on the inside, where it kind of looks in the middle of the beach ball, I should say, and it kind of looks like a cat's eye, uh, that is going to be more reminiscent of a reverse fault. Now, you'll also notice how we have this little crosshair that's happening right here. It's not a perfect reverse fault like you see in the example that I circled over there. What you do notice, maybe, right, let me move that over here. What you do notice is it mostly looks like a reverse fault, and there's another example down there that looks like a reverse fault. It's called an oblique reverse fault. And basically what's happening there is you got to imagine that this brick, so if here's a brick house, if the fault was going that way, it's representing this one right here where this block is kind of moving to the side, but also up. All right. And then this one would be the one on the right, would be representative of this fault. That's kind of what this is showing us right here. And that is showing us that this sucker moved. Let me erase that so you can see underneath it. It kind of moved towards us and up. Trying to get my pen. It moved up this direction, all right, and also over a little bit that way. So it's not just up. It's not like a typical reverse fault where it's just up. It's up and it slid over. And I think you can see it really good in this one right here, where you can see the fault block moved up and was also offset horizontally or laterally just a little bit as well. Okay, so this is what we would call an oblique reverse fault. So here's where it gets a little fun, I think, is if you go back and take a look at this, what's kind of cool is we can see literally if it's a reverse fault, we can know which one is the head wall and which one is the foot wall looking at this because the head wall is going to go up. So this would be our hanging wall or head wall. So I'd, put like HW right there. And then the drop block would be relative to the other one. So that's going to be kind of our foot wall over there, or yeah, foot wall. So that's how I would label that. And remember, the first two didn't have a hanging wall or foot wall because they were strike slip faults, and there's not really much huge vertical displacement relative to one side or the other, like you're seeing right here. Okay, so that was number three. And then the last one, number four, again, this one should be fairly easy here. Going right down the middle, okay? Let's see. Gosh darn. Sorry, my tablet is a little old and I'm trying to find my mouse cursor over there so I can drag things around for you. Okay? So when we're looking at this sucker that's right here, man, that was kind of a poor drawing. So let me make sure I can get that so it's good. Let's see here. End to end. There you go, like that. That's better. All right, so if we're going back over to this other side, right over here, to look at the focal mechanism, basically what we're seeing here is it looks similar to kind of like an oblique reverse, sort of, kind of, and it also looks like a strike slip where you can see the almost BMW logo of that kind of poking out there. But what's different about this one is that instead of the blue parts being in the middle, the white parts are kind of in the middle. So this would be almost like an oblique normal fault that we're looking at here. More strike slip than it is normal, but that's kind of how we're going to look at it. So there's two possibilities. That fault plane, if it were in on that circular plane there, one option is that. And remember I showed you how you just kind of, if you just imagine that this is that three-dimensional plane and that surface kind of go on like that, could make the fault that goes through there. So if you do that, if you're kind of connecting the ends of those suckers, it might help you see a little bit better or imagine it. You'll notice that that line very much represents this right here. And if that's the case, remember white pushes blue. Man, I'm trying to draw here. Whoop. White pushing blue there, white pushing blue right there, and I drew my arrow upside down like so. So basically what we end up with is kind of this left lateral strike slip motion, but also normal faulting with a little bit of down dropping. All right. And so if I were to draw this, I would probably draw an arrows that look like this on the fault. So you kind of get that sense of that was most of the displacement. And if I'm looking at the interferogram, the let's see here. We have blue, yellow, red on the top side. So blue, yellow, red means the land drops. So this is our droppy drop side. And then here is our, let's see here, blue, red, yellow. This would be a little bit of uplift, relative uplift or so. Okay. And so what I'm thinking on this one, remember in a normal faults, those head walls go down. And as it slid down, it kind of somehow allowed, as it was sliding to the left and right, this kind of hanging wall dropped a little bit, and then that would make this part um, the foot wall right over there that also uplifted slightly as the fault was being offset to the left and to the right. Or actually, well, you can see here, left to the right. Okay, right lateral strike slip fault on there. Or if I was standing over here, to the right. So I know I'm tired, and maybe this wasn't the best explanation, but I'm trying here. All right. So here's kind of the answers. You can go through, take a look at those, match yours up, do your best to see stuff. And then as you're choosing your focal mechanisms for the rest of the evening, or for your other assignment from last Friday, maybe these visualizations, the stuff that we drew, might help you out. But really, what I really care about and what I really want you to be able to kind of recognize, because what you're doing was pretty intense and pretty advanced stuff here, is I want you to be able to recognize, hey, if I see a focal mechanism that looks like that, that's a strike slip fault. If I see one that looks like that, that's a normal fault, where the white is in the middle. Okay, so remember with this one, you'd have the pressure pushing out on both sides, and then on the reverse fault, the pressure is squeezing in. So you get the compressional there versus the tensional and the normal. So the reverse fault has the blue in the middle, and those oblique ones, um, well, they can be oblique reverse or they can be normal oblique as well, depending on what the color is on the inside. If it's blue or dark on the inside, that's reverse. If it's flipped where the white is on the inside and the blue's on the outside, then it's going to be like an oblique normal fault. So that's how you read these. You guys, let me stop sharing my screen here. You guys, I gave you a lot of real world examples. I didn't really give you any kind of textbook, clean, practicey type stuff. So if you were struggling a little bit, that's okay. It takes a long time to kind of have these things sink in and make sense. But I wanted you to be introduced to it. So then when you click on an earthquake later on in your life from the um, earthquake catalogs, you'll be able to tell, hey, it's a normal fault or it's a strike slip fault. Or if you see one of these pop up somewhere, like, well, here, let me see. Let me share my screen and go up. There's our two mass, but let's see here, latest quakes. So this morning, it's Tuesday now. This morning there was um, an earthquake. Sorry if you're getting sick there. Just north of San Luis Obispo in Templeton. So I went to Cal Poly, so I know this place really well. But it's a 4.1. It actually showed up pretty nicely on my seismograph. But after a few minutes, they got enough information in there. Ooh, hey, look at that. This is the moment tensor that happened for that earthquake. So what we can see, and hopefully you know now, is if you compare this, you'll see that uh, the blue's in the middle. So if it's blue in the middle, the first thought is, oh, that's kind of a reverse fault. But because we can still see a little bit of the, let me get my pointer so you can see what I'm talking about here. So here's the blue part in the middle. So that's what's gonna make this the reverse component. But because you can kind of see where the fault planes intersect over here, tells us that it's an oblique reverse fault. So not only was it going up and down, but it was also sliding, in this case, to the north and on one side and to the south on the other. Okay, so that most likely fault plane, if I were to draw that, right, would be probably something like that from one end of this node, and you got to kind of imagine where the other side of the node would be over there. And so if we were to look at this in real time, let me unclick that now because now I don't have my tablet. Oh, sorry. Oh, I know what that is. I'll just move this over here like that. My suspicion would be either you could have a fault running like this, or The other thing is, if you're going back um, this a direction, you could also have a fault running. Oh, there's our end. It could also kind of go, basically it would go up and over that way, run in that direction. So who knows? We'll have to see, but get that. We'll have to see which way those fault runs. And so I'm curious, I'm wondering if we put on the faults there, if we can actually see what direction that sucker is. But what we do know is that it is a oblique reverse fault. Let me put on the actual faults and then we'll be done. And you guys can fast forward through this, I suppose. And there you go. So this one's not actually on any fault, which is kind of interesting. The reds there are the mapped faults, so it's not quite on any of the mapped faults, but it is on a strand that seems to be somewhere in between these strands that run parallel to the San Andreas Fault. So maybe there's some compression there somehow, and that's how we get this little bit of a reverse fault. So anyways, that's how those look. That's real time. That's what happened today, and kind of a cool coincidence that this all happened. So with that being said, hopefully that clears up a little few things, at least give you some of the right answers to take a look at, and then um, do that Friday one from last week when you're looking at the focal mechanisms if you haven't started there. And then if you have any questions, we'll talk about it when we get back from Thanksgiving. All right, so have a good night, everybody. Take care.